Hello everyone, welcome to my YouTube channel. Today I will discuss about one interview question which was asked in Joho in AI engineer interview. A user asked the same question 100 different ways. So how do you cut the LLM cost without cutting the correctness? This was the question asked in Joho. So what happens? The cost explode on the repeated intent. Same question worded 100 different ways. Every paraphrase triggered a full LLM call. Like if you are saying what's your refund policy and someone asking, can I get my money back? Hit the model for the same intent. So twice, two calls happening for the same business use case. So we have to, so this increases the cost of LLM. Spend scales with paraphrasing, not with the real demand. Cost grows off without the semantic meaning. And exact match cannot be helpful here because if we try for exact match, so the probability is very less. So semantic caching is the thing which we can prevent, which we helps us to prevent this cost. So what is exact match case? So keys on identical queries means you have to query on the keys, zero hit rate across paraphrases, simple, cheap, and predictable. Fine only for the literal repeats. But but the semantic cache, it keys on embedding similarity, not the exact test. Catches paraphrases and reordered wording like what is my refund and refund for this item are similar in meaning, but we need to check the intent also. Sometimes what happened when you are saying refund policy and return policy, maybe they are both similar in embedding, but the intent is not similar. So that is one thing we have to take care here. And we need to needs a similarity threshold and freshness check here. And sometimes we can overmatch on surface similar but different intent. So we have to check that similarity threshold also very carefully. So what cache uh, guarantees? So it gives low latency because you are not directly interacting with LM with some latency also will be there. So cache hits should return in milliseconds, and it will do a meaningful cost reduction around 60 to 80% of the cost reduction happen if it is the repeated questions are happening. And it can give no confident wrong answers because it is already proved, and that's why we have kept it inside cache pool. Freshness is tied to the source data. So how cache always not outlive the truth of the source they came from. Safe in multi-tenant use. So one customer cached answer must never leak to another, and it should be observable and auditable. So the read path of this one is like a user asks a question, and then we will embed that question into the vector database and search the cache for the nearest match. If the similarity matches means if the similarity matches with our threshold, like we have kept 96%, then if it is then we will check the freshness also. And if it is cache hit, we will sub the cached answer instantly, and if it is not, then we will make a fresh LM call. So there are some safeguards against wrong answer. So we have to check the time to live and version expiry. And another thing is source linked invalidation. We have to invalidate the entries from the source, and we have to version that one also. And sometimes we have to do a threshold tuning also. So a missed cache hit is cheaper than a confidently wrong answer. So we have to set that threshold very uh, and then there is a confidence check also. So cheap model will do a confidence will confidently answer the wrong means wrong answers. So we have to do a model versioning also for the same. So there are two ways where a cache lies to you. One is so sometime when customer asks refund policy for electronics, so sometimes what happen, it will just check the general refund policy and it will, because of the similar wording, it will but different intent, it will the wrong answer will get served with full confidence as that is the false positive. And staleness also, because sometimes what happen, we have not invalidate our cache and our policy changed last week, and then but it is serving from the cache which is older than that. So that is also one problem with cache, so that we have to do the cache eviction policy. So there is you have to, if you are monitoring cache in production, so you have to check what is the cache hit raise, what cost it is saving for the last week, and what is the false positive rate, and P50 and P95 percentile you have to check. After if you are doing happy path, so beyond the happy path you have to always do a two-tier cache exact match in front of semantic, and uh, you have to strip pi before embedding, and it should be isolated per tenant, and preload embeddings for the top FAQ answers, because if you generally 80% of questions are repeated, and it's frequently asked questions, so you have to list down that one, and you have to continuously audit your cache label, and category wise also you can do your thresholds. So the the takeaway is that key cache is the meaning, not the words, and never trust a hit you haven't checked for freshness. So that is, now we will go on the system design, how we have to proceed with this kind of uh, problem. So let me start. So this is common production problem in AI systems, and exact string caching doesn't work because user asks the same question in different way. What is the capital of France? Tell me the France capital, which is the city of. So all four questions have different questions are different. The answer is identical. So we are making four different calls. So it waste token and increase latency. So we will draw one high level uh, architecture. So this is our user query. Then user query, we have to do query pre-processing. So this is very important step. We have to, generally we will normalize. Normalize means it may contain some of the Roman keywords or something, or maybe it can have a, multilingual things also. We will remove some of the noise, and we can lowercase it for the proper embedding. So this also are important step while while doing while designing this kind of systems. After that, we will have our embedding model. So that also we have to select very carefully how what type of user queries are coming in. And after that, we have our vector embedding. So vector embedding will be generated by the embedding model. So if we are selecting different embedding model, if it may vary on the provider also, like OpenAI is giving different model, then then the open source one. So we have to select that one. After that, we will having the embedding. Now we have two paths, means will save our metadata also, because that is very important part. So while we are doing the vector embedding, right? So we have to do metadata, metadata store, where we will be storing the TTL, version, and source. So this is the thing we have to store in the metadata store, and here we have to do the vector db, and here we will have to cache the embeddings. Everything we will be storing here. After that, now the main algo comes into the picture. So we have to check a similarity. So here we have to do a similarity check. So similarity if similarity is greater than threshold, we have to set some threshold that it is this much percentage matching to this one. If it is yes, then we have to validate for the freshness. And after that, we have to return the cache answer. And similarly, if it is this is for the yes case, and for if it is no, then we have to go for if it is no. So we have to call LM, call rag plus L, and then we have to generate answer. So if I will repeat it, so first user query will come into the so then this query pre-processing, we will normalize the user input, and we will remove the punctuation, stop words, extra spaces, emoji, casing difference, and then after that, from the embedding model, we will generate the embedding. Instead of caching the raw text, convert every question into the vector, and we can use there are popular model like OpenAI text embedding 3 small BG, E5, Voyage AI, and instead of we will store vector as an answer. Then we will do a similarity check here if all the stores. So similarity, incoming query embedding search for the nearest neighbors, So, for example, we have kept 0.96 similarity score and threshold is 0.92. So, since if it is matching 0.96 similarity, then it will be a cache hit. And from the cache hit also, we will check for the freshness also. And how we can prevent wrong answers. So sometimes what happen, never written answer solely based on the similarity, but we have to validate additional constraint like intent match. Like if we are saying refund policy versus return policy, similar embeddings but different business meaning. So and similarly, we have metadata store where we will be using our versioning of and here we will be storing how fast we have to invalidate the old cache and what are the source and what is the TTL. TTL is time to live. So how weather can be 10 minutes, time to live, HR policy can be 1 day, and documentation can be until a new version. So so that is the thing. And if we are not able to match the similarity, we will directly call the RAG and we will generate the answer. So this is the basically the answer for that.